And now I would like to invite here on stage our first keynote speaker, who is Professor Stelian Brad. Stelian Brad is president of Cluj IT cluster and professor in intelligent robotics and innovation management at the Technical University of Cluj. Stelian Brad has a complex background of about 20 years in software industry as CEO, product or project manager, innovation manager, entrepreneur, and mentor. His current technological focus is on disruptive IT, product service systems, Industry 4.0, and robotics intelligence. Stelian, please.
Thank you very much for the introduction, and good morning to everyone. I first of all like to congratulate all of you because of this very challenging headline of the conference these 2 days. I think you made something that raised up the standards of programming with art of programming. I even questioned myself to see what is this art in programming, and I remember about the martial arts actually, and I see, okay, martial arts about the aesthetics of doing something and about the effects. So finally, I'm just very much curious to see what is, which is the aesthetics of doing programming. I'm sure that our colleagues will reveal us this, but for today I'm going to switch a little bit in my presentation, and I'm going to talk about how programming can support art. And maybe a little bit how programming can do art. It's not necessary to introduce a lot of technical stuff, even if some technical issues will be part of my presentation, but more to send a message to the Cluj community, because it's strong in IT and it's also very strong in the field of art. And we talked a lot about developing an emerging industry called creative industry. So I think, and I hope through my presentation to inspire you and to see from now on more projects working together by programmers and artists in the attempt to have expansion of human expression. Therefore, I'm talking about how coding can be used to make art. And I start with this picture, with this painting. Do you know this painting? It's an unfinished painting. Was sold 1 year ago in New York by Christie's with more than $400,000. Why about this unfinished painting? Is not something very new. It's even coming back from Renaissance, because a lot of artists, famous artists like Michelangelo, Da Vinci or Tizian experimented this. Then in the 19th century, we had a lot of movements in this direction, and that was the born actually of the modernism in art. But what is important with respect to this painting, it was not done by a human. It was 100% done by computer. And actually, it is a special algorithm used by artificial intelligence called Generative Adversarial Network Algorithm that made this possible. Of course, the data set was supported with more than 15,000 paintings from several centuries, and this is the result. So, from this perspective, we have to see 2 important issues. One is the aesthetic value of artwork, and the other one is the economic value. This painting is also 100% generated by computer. I wrote a simple code to make this happen. And in this respect, sorry, From my perspective, what is important to understand in this message is not necessarily the definition of art, but specifically the outcome. I mean, the emotion a piece of work generates in front of a viewer because of shapes, because of colors, because of meaning. You see, also these paintings are done by computer, 100%. So in the next minutes, my invitation to have a short journey to see how computers can create beautiful pieces of artwork. And as I said, it's a pleading for a combination of the work of machines and men to do interesting things together. I'm going to talk a little bit about how programming can support a transfer of style in paintings, or how we can create new paintings, or even how we can transfer a style in the painting to the level of a photo, or even how we can train robots to make art. And I'd like to start with the use of artificial intelligence in this respect. There are several algorithms that are already experienced in doing artwork. You see 4 of these algorithms in this slide, and let's have a look at some of the results. This is the convolutional neural network where we can transfer the style from a famous painting to a photo, for example, where you use convolutions to make a kind of style reconstruction and then a transfer of the style into any kind of photo you maybe like to have and look like a painting. Or using other algorithms like creative art network algorithm to transfer from some paintings different patterns, different styles, the most representative one to the level of photos and having something looking like a painting. Or another example with convolutional network, from figurative artworks transfer to the photos and having new paintings, new styles, as you see in this slide. Or this example, this is done by Google Deep Dream, as you maybe heard, algorithm, the deep style and the thin style, and the same artistic or aesthetic effects we can have by this. This is another example of a deep dream algorithm, not necessarily to say it's an artistic piece of work, but maybe it's a little bit of fun, because the algorithm identifies different shapes in the original photo and then try to replace with some figures, with some objects it has in the database, and then to create a kind of artistic style. Other examples where 2 figurative paintings can be transformed into a new paintings by convolutional neural networks, or the creative artist network doing the same thing. It's important here to highlight the importance of the art, or maybe combining 2 paintings to generate a new one with an aesthetic effect. Or what is here? Considering one of the painting the base and the other one the style, and vice versa, you can even generate a new type of paintings with a stylish effect brought from one painting to the other. Like here, one is snowy, more icy, but also we can judge about quality of doing art with artificial intelligence. Do you hear sound? I think it's important because it's also with sound here. You can have a target, you can extract some features from another painting, and then by integration, you can generate a new type of painting by using also artificial intelligence. Sorry. This is how generative adversarial network actually operates in order to produce new paintings. Actually, there are two networks that act together, and based on this, it's a final result of a new painting, because one of the network tried to cheat the other one and introduce a fake painting into the data set. It's a kind of play, a game between the two networks, and finally, by adjustment, you will generate the new result. Exactly this algorithm has been used for the first painting I introduced. And why not to reborn some passed away artists? This is an interesting piece of work, because in the Netherlands, some programmers and artists work together using algorithms for feature extractions to generate a completely new painting of Rembrandt. Something that is never done by Rembrandt, but the result looks like it's done by Rembrandt. So let's look together what happened. Actually, it's not artificial intelligence here, but it's about mathematics. It's about extracting features, identifying patterns of the style of painting and of brush lines, and then using all these informations, putting in a database and comparing with actually a large data set of paintings already done by Rembrandt to invent a new painting, a new portrait actually. And I said this is a quest for immortality, because with computers we can reborn artists. Now, with special printers, we can print paintings in oil, like a painting. This is not anymore niche. And now this is the result. You see the level of details. I think even an expert in Rembrandt with difficulty will say that this is not Rembrandt. So, why not having our portrait done by Rembrandt with this technology? This is a quest. Sometimes we can use special algorithms to create a kind of style or pointillist to paintings. I made a short code, and from a photo I can generate something that can look like a painting. See here, a short exemplification with our city, where I've used creative key-means algorithms for doing this. And you should compare the original photo, which is a photography, with something that looks like a painting. First of all, you have to extract the palette of colors to see which are most representative, and then to generate different styles for the lines in the photo. Or why not using computers for the so-called generative artwork? where we use classical mathematics to generate aesthetic effects. We have here both static generative artwork and kinetic generative work. These two results you see here in the slide are done by 100% by computers. The first one with fractal geometry, this one with a little bit of mathematics I have introduced in the code. And look to some examples of static generative artwork. This is done with a specialized program called processing, which has behind Python, for example. Or look here, how simple is the code, but look to the beauty of the results. By little changes in the values in the mathematical formula. And why not to see the hidden side of mathematics, because many of us are not very much pleased about mathematics, but look to the formula above and the aesthetic effect of this formula. Or here, we can see complexity is art. Nature is art because please us very much when you look to a landscape. But to the end of the day, we can look to, if you know the rules behind, you see that complexity is not complex, simple. As you can see in this result here. Or some other examples of small pieces of code, but with a lot of understanding of the creative, of the aesthetic effect you can generate by doing this. And I introduce here some other examples of kinetic generative artwork using traditional mathematics. This is Python in an environment of processing to make this. Or other examples with fractal geometry. You know about fractal geometry, where some kind of rule is replicated in different way and generate nice effects. In the picture in the right top corner, you see a kind of battle between two styles of fractal geometry. Or even you can connect these kinetics to music to have an additional aesthetic effect. So not stopping just on paintings, but also on other kind of arts, like music, for example. Or other possibilities. Possibilities actually are endless. Using defragmentation algorithms, behind there are some photos, but you can identify the lines and the thin or the thick of the strokes, and then you can generate different kind of kinetic effects. This is also processing and Python. You see, from the identifying the pixels, the lines, and then generate some kinetic effects with randomized colors and patterns. And with this very simple example, I'd like to demonstrate that even programming is an art when you have to create an artwork. It's about the emotion it creates to us when watch. Or sometimes you like to use this as an interactive work with the viewer. These are just stupid examples, but where you let the users to create his or her style. It's a little bit of play, why not? For kids, could be very nice. I'll skip a little bit because of time constraint, but yeah, we can talk later more about this. But why not expressing artistically using basic programming and ASCII code? You see, you can replace the pixels in the photo with some letters, with some sign, and you can get these results, or these results. Or such aesthetic effects, just with simple ASCII code, as you can see here in the zoom. Different letters and signs, ASCII. Or generative work using artificial intelligence where you create your own data set and then use the algorithms to inspire from data set to create unique styles. And this could be also a source of inspiration for artists to have or to imagine new styles of paintings. This is a kind of so-called psychedelic artwork, but it's important about the effect, the emotional effect, because of combination of colors and shapes, and about the meaning in respect to the culture of the viewer. And these are some results. You can judge if they create an aesthetic effect, an emotion to you or not. I stop a little bit because no more time, but you can see here combinations using these results with artificial intelligence. And you can see different type of results, like this. Or even you can stylize different symbols, like this example. Or this one, or even this one. Or combining famous paintings, there is Dali with artwork, generative artwork, and artificial intelligence, you can get interesting results too. Or this one. Or here, the same thing, but with another algorithm. Or if you like to have the painting of your kid, put in the computer and introduce in the style, some shapes and colors, you can get also a piece of artwork here, too. The time is not so much. I will skip a little bit because I have also introduced something about robots doing art, but I would like just to end with, this will be for another maybe presentation, I would like just to end with a kind of bonus, transferring from painting to music using coding and artificial intelligence, a short demo. Maybe sometimes we like to hear some favorite songs, but play with other instruments. And you can have results. This codex also in Python. You see different instruments like trumpet, vibras, bass. You can explore also here, or Deep Purple if you like, but maybe with other instruments. So you can explore even more. I will stop here with this, but also you can hear some traditional song, but you can create your original orchestra, like this one, with bells. Or why not hearing a new composition of Bach using deep learning? This is not created by Bach, but you can imagine it looks very much like Bach compositions. The same data set of works done by Bach was introduced and generating a new piece of art. Maybe you like to hear the sound of sine or other kind of mathematical function. Would you like to hear? Okay. Maybe you could expect it something like this. Huh? Or maybe the sound of a picture or of a painting. Here you can transform pixels, color of pixels actually in different mathematical rules. Or, and I will end with this, let's see the sound of our solar system. Using different instruments and the speed of our planets around the sun. This is a kind of celestial music, so we can explore new spaces. So, my conclusion is there is a lot of space to explore in the world of artworks, in the world of artistic expression using computers, and I invite both artists and programmers to work together to expand this space of exploration. Thank you very much.